Hello everyone, welcome to V4. I am Kamal. In the series of number system series, we are continuing with LCM and HCF. In last videos, we discussed about basics of LCM and HCF. Now, hereafter, we are going to solve questions that is mixed with both LCM and HCF. So, let us begin our video. This is the first question of this video. So what is the question says is a red light flashes 3 times per minute. Okay. A green light flashes 5 times in 2 minutes. Okay, at regular intervals. So if both the start together, how many times do they flash together in 1 hour? So the thing is here 3 times per minute, 5 times per minute. If I know for every what time that red light and green light will flash for one time, at what interval they will flash. Okay, then if I take LCM, I can find the value. Why I'm taking LCM for that? Because LCM, if I take for two different times, it will give a common time that happens for both the events. So here, red light, red light flashes 3 times in 1 minute. In 1 minute, we have 60 seconds. For 60 seconds, it blinks 3 times, which means for every 20 seconds, it will blink once. Again, next we are going to discuss about green light. For every 2 minutes, it blinks us 5 times. So in 2 minutes, we have 120 seconds. If I divide 120 by 5, I will get at what interval of seconds the green light blinks. So 120 divided by 5 is nothing but 24. For every 24 seconds, it will blink. If I take LCM for 20 and 24, I will find at what time both these lights will blink together. So into LCM for 20 and 24. So 20 is nothing but 4 5s are again 24 is 4 6 are. LCM is nothing but common value which is 4 here multiply uncommon value which is 5 and 6. 4 5s are 20, 26 are 120. For every 2 seconds, for every 120 seconds which is equal to 2 minutes, both red light and green light will uh, glow each other, flashes at same time. In 2 minutes, they will flash together. In 1 hour, we have 60 minutes. So we have to find in 60 minutes how many times they flash together. 60 by 2. So ones are 37. In 60 minutes, 30 times they flash together. So that's how we find. So that's why if you take LCM for two different numbers, the LCM will give the common number that happens for both these two different numbers. So this is the second question. I want to find both LCM and HCF for this fraction. Always remember, I want to find LCM for fractions, which is equal to LCM for numerators divided by HCF for denominator. Then the HCF for fractions is equal to uh, you just need to take HCF for numerator and LCM for denominator. So this is what we need to find. So if we want to find LCM for 2 by 9 comma 8 by 21, what is my value? For this I need to take LCM for 2 comma 8 divided by HCF for 9 comma 21. So LCM for 2 and 8 is 8 itself because 8 ones are 8 because 8 is multiple of 2. HCF for this is uh, 9 is 3 3s are again 21 is 3 sevens are. The common value between these two numbers is 3. So this is my LCM. So for my HCF, so what is the something but 2 by 9 comma 8 by 21. So something but HCF of 2 comma 8 divided by LCM of 9 comma 21. Here the common value is 2 here in the numerator. Denominator, so we will multiply with common value is 3 and uncommon value is again 3 into 9, 3 into 7, so which is equal to 2 by 3 square into 7. Okay. So this is equal to 9 sevens are automatically 63, 2 by 63. This is my answer for both LCM and HCM. I hope you understand this question. Let us go to next question now. A bookstore, modern bookstore is a flash using neon lights. Okay, there will be a board. Name in the board we have letters, a word as modern bookstore, and each of these word is flashed with neon lights. The word is flashed at the intervals of 2 1 by 2, 4 1 by 4, and 5 1 by 8 seconds respectively. Each word stays for 1 second. Find the least time after which the full name appears again. So for every 2 1 by 2, 4 1 by 4, 5 1 by 4, these are in mixed fraction. If it is in proper fraction for some numerator and denominator, I can take the LCM. So how to, for example, if it is in the form of A, B by C, it is a mixed fraction. How to convert in proper fraction? Just nothing but AC plus B by C. This is my fraction. Similarly, we will convert all the three mixed fractions into proper fractions. So 2 1 by 2, which is equal to 2 2s are 4, 4 plus 1 5, 5 by 2. Again 4 1 by 4, which is equal to 4 4s are 16 plus 1, 17 by 4. And again 5 1 by 8, 40, 40 plus 1, 41 by 8. So these are the proper fraction. So the problem here is, if just blinks and off means that doesn't matter, but it blinks for 1 second more. So which means if it flashes at this time, it will stays for one more second, which means it is equal to, so for this time 5 by 2 plus 1, the light correctly offs, blinks and offs, blinks and offs. So similarly, it will equal to, if we take this LCM, it will become 7 by 2. Here it is going to be 21 by 4. Here it is going to be 49 by 8. So this is the time that correctly blinks and offs the lights, the neon lights blinks and offs. So if you take LCM for all these three value, 7 by 2 comma 21 by 4 comma 49 by 8, I will get a common value. That common value is nothing but the common time where all these three lines blinks exactly offs. Okay, so why am I adding plus 1 here? Because first time it blinks at 5 by 2 seconds, next time it offset not 5 by 2, it's offset 7 by 2. So next time it will add again 5 by 2 plus 5 by 2, which is nothing but 12 by plus 1 second. It will again stays there. So instead of 5 by 2, next time it should be close at 10 by 2, but instead of 10 by 2, it close at only at 12 by 2, and switch off at 13 by 2, so 15 by 2. So this changes will happen here, so we have to careful with that. So this is nothing but LCM of 7, 21 and 49 divided by HCF of 2, 4 and 8. So HCF of 2, 4 and 8 is 2 itself, because 2 is common for all the three numbers. It is 7 into 1. It is 7 into 3. It is 7 into 7. So common value is 7. So here uncommon value is 1. Here uncommon value is 3. Here we have one more 7, which is uncommon. So it will become 49 into 3. It is 120 plus 27 is 147 by 2. And for every 142, 147 by 2 seconds, we can see the entire full name there. Okay. So we'll go to next question. I hope you understand. You just need to careful with this. It stays for one more second means we just need to add that initially to avoid the confusion, and just need to take LCM. We'll get the answer. What's the next question? The product of two numbers is 100. If the LCM is 25, we need to find the highest common factor. Okay. So always remember this particular result. Let us consider two numbers as A and B. If you multiply these two numbers, which is always equal to LCM into HCF. So here, product of these two numbers is 100. Just the LCM is 25. We want to find the highest common factor. Now the highest common factor is nothing but 100 by 24. 25, which is equal to 4. So now we know the answer. The highest common factor for this is 4 now. Now once this is done, the answer question is will be done. But I will explain why it's so. So I'm assuming A as some x into A. It x can be 1, 2, 3, whatever. Okay. B as some x into B. If we take LCM for this, A comma B, which is nothing but HCF into uncommon number. Yes or no? Here HCF is x. Okay, if we take x, sorry, we are not taking LCM here. We are just producing A and B, which is x into A into x into B. X into x will become x square into A into B. So if we take HCF for A comma B, what is the common value here? This x. If we take LCM for A comma B, what is the LCM here? The common value into uncommon value. X is common, remaining A and B are uncommon. So if we multiply these two also, which is also equal to x square into A into B. That's why. So just this is always equal to this one. Okay, that's the result. So that's about this question. We'll go to next question. What is this question? What is the smallest integer of n? Okay, the n should be smallest integer. Okay, and such that the LCM of n and 30 is 180. So n is some value 30. What is 30? 6 5 are 6 is nothing but 2 into 3. So 2 into 3 is 5. LCM is 180. So 180 is nothing but 2 square into 3 square into 5, because 180 is 18 into 10, 18 is 3 square into 2, again 10 is 2 into 5. So always remember, okay, we know LCM of A comma B, which is equal to HCF of into A into B, uncommon numbers. But here the question is, we don't know the value. We know the LCM value. In all the previous question, we know the value of A and B, we found the LCM. But here, we don't know the value of N, but we know the LCM value. So I will just explain this small explanation how to solve this. Let us consider two numbers. If I want to find LCM of 12 and 16, what is my answer? 12 is 4 3s, which is 2 square into 3. Again, 16 is 2 power 4, which is 16. If we take LCM for this, what is the common number here? 2 square is common. Remaining uncommon numbers are 3 into again 2 square, which is 48. So which is also equal to 2 power 4 into 3. Here the thing is, if I take LCM for two different numbers, well, my LCM is nothing but if there is some common prime basis, my LCM will take the highest power of that prime base, which is 2 power 4. Even though, is that because HSFP is 2 square, and the remaining is 3 and remaining 2 square here, because it will become 2 square into 2 square. So 2 square common, remaining all the uncommon numbers, just 3 and 2 square will multiply. So instead of doing that, if I don't know the name, if I don't know the value of these two numbers for which I'm taking LCM, we have to always focus on prime basis and its power. You can see that here I have 2 as prime base, here also 2 on power base, 2 as my prime base, but in LCM it takes the highest power, which is 4 here, and remaining all uncommon numbers, which is 3. So I can see 30 we have power 1, for 3 as power 1, 5 as power 1. So I can say 2 also will made by 2 into 3 into 5 with certain powers as A, B and C. This A, B can be 0 or some value which is more than 0 also. So here I have 2, but here the power is 1, which means in n I have 2 power as 2. That's why, since the common base which having the highest power will be my LCM like this, which means the value of A is 2 here. Similarly, it is happens for B. Only when B equal to 2, my LCM will have 3 with power as 2. And C, it can be 1 or 0. But since I want to find the smallest value of n, I am considering C as 0. Because the highest power of 5, that is 1 year, I am considering it is having only with 30, not with n, so that my n is 0, because I want to find the smallest value. So now n is nothing but 2 square into 3 square, which is 36. Okay, so I hope you understand this question. If I don't know the value of numbers which I'm taking LCM, I need to focus on prime bases with powers. So if sometimes if there is some common prime base means the LCM will take always the same common price with the highest power. Okay, based on this, I'm solving this question. We'll go to next question now. So this is an interesting question. What is the question says is if the LCM of first 120 natural number is k, find the LCM of first 125 natural numbers in terms of k. Always there is a remember there is a LCM rule. If I take LCM from 1 to n, I will get LCM is nothing but product of all prime numbers from 1 to n with highest powers of each prime number in a number. What is meant by that is from 1 to n, if you want to find a group of numbers LCM from 1 to n, so the LCM is nothing but product of all the prime numbers. But the problem here is I need to focus on powers. So I need to product all the prime numbers, and the powers of each prime numbers is nothing but what is the maximum power of each prime number can take in any one of the number from 1 to n. So you just understand this while solving this question, you will understand better from 1 to 120. So if I take LCM, which is nothing but product of 2 into 3 into 5 into 7, it keep on goes. This what is the prime number which is less than highest prime number which is less than 130 is 113. So for 2, what is the highest power it can take? So we know 64 is nothing but 2 power 6. The highest power of 2 in any number from 1 to 126, which means its power going to be 6. For 3, highest power of 3 in any number is 81, which is 3 power 4. For 5, it is 25, which is 5 square. For 7, it is 49. From 11 to 113, we have highest number powers of prime numbers. Any number is going to be 1 1 1 1 1. Now we want to find, so this is k value. We want to find LCM of k comma 121 comma 121 to 122 comma 123 comma 124 comma 125. So the LCM is nothing but from k we already have some numbers. So some numbers are powers which is does not have here. So this LCM is nothing but k into the prime numbers having more powers in a single number that doesn't exist in k. That's my LCM. So it's k. So 121 is 11 square. The highest power of 11 in any number from 1 to 120 is only 1. But here we have one more 11 square, which means already have one 11 in this k. I'm multiplying one more 11 so that this number will already again will become some multiple of 121. So 122 is nothing but 2 times of 61. So 61 is a prime number which is already a part of k. 2 is also part of k. So there is nothing we need to newly add. It's for 123, which is nothing but 4 times of 31. So 31 is a prime number which is already part of k, and 4 is also part of k because 4 is 2 square. We have 2 power 6 as k. So it is also possible because k is also multiple of 123 and 124, which is nothing but 4 into 31. I think it is 3 into 4 are it is 3 into 41 It is 4 into 31. So 31 is also part of this k and 4 is also part of this k. 125 is 5 cube. The highest power of 5 in any single number from 1 to 120 is 5 square only. But it is 125, which means I have 5 cube now, which means I have to multiply one more 5 because I have in k I already have 5 square. So 5 square into 5 will become 5 cube, so that this number will be multiple of 125. My answer for this question is 55k. That's my answer. So with this, I'm stopping this video. I hope you understand this question clearly. So with this, I'm stopping this video. Thank you.